Hey everyone, welcome to Lecture 2 of the Quantum Student Society lecture series. Today we're going to be continuing talking about fundamental math and specifically complex numbers. So we'll be discussing why we need a complex number for quantum science, what is a complex number, division, an example of complex numbers in a problem. So why do we need complex numbers for quantum science? Well, a quantum state for a qubit is written as a superposition of two basis states, meaning if you have a qubit, it can either exist in an alpha form or a beta form. And in quantum science, we say they usually exist at the same time. So alpha and beta must satisfy this formula where alpha squared plus beta squared equals 1, which guarantees a probability of that occurring 100%. So what is a complex number? You might have seen this in algebra before, represented as I. So you can write a complex number z equals a plus ib, where I and b are real numbers and I is the complex number. So simply imagine a complex number has a real a, like we said, and imaginary part ib. So what makes the part imaginary is the I squared. Well, the I squared is minus 1. So like complex numbers, you can add, subtract, and multiply these numbers. So for addition, it's kind of like vectors where, you have this complex number 3 plus 4i, and this other one 5 plus 3i. So you add the real number part, 3 plus 5, which is 8, and then 4i plus 3i, which is 7. And for multiplication, again, if you, for example, have 3i plus 4i, and you're multiplying it with 5 plus 3i, then, you'd get, well, we have this formula right here, so you would get 3 times 5 minus 4 times 3 plus, now you add AD, so 3 times 3 plus 4 times 5 multiplied by the complex number part, which is I. And this will basically be 15 minus 12, which is 3, plus 3 times 3, which is 9, plus 20, which is 29. 29i. So that would be basically like the multiplication for these two. And that's how you multiply complex numbers. And obviously, addition and multiplication is pretty easy, but as you can see here, division is pretty scary. If you're dividing a plus bi divided by c plus di. This would be the formula for it. As you have this and you multiply, this is essentially 1, right? Because you're multiplying and dividing by the same number. And then you combine these terms and you end up with this. So an example of a complex number in a problem. Well, referring to our original, how you write a quantum state, written here, this is alpha, right? 3 plus 4i. Beta is 0. Well, we can ignore this. So how would you normalize this quantum state? Well, you do that by taking your alpha term, right? And then you multiply this a and b components and you square it. So 3 squared plus 4 squared equals 25. And then you square root that 25, which is equal to 5. And then you write that and you put that into the denominator. So then your quantum normalized state would be 3 plus 4i divided by 5. And that's all we have for today. And I recommend you guys to check out our next lecture on quantum states and superposition. Thank you.